Welcome to part two of doing basic time value of money calculations using the Hewlett-Packard 12C calculator. Now there are a couple of other types of calculations we need to know how to do for basic time value of money problems. The first is the present value of mixed streams of cash flow. A mixed stream is a series of differing cash flows. So for example, you have an investment that provides cash flows of $100 the first year, $200 for the next 2 years, and $400 the fourth year. Our required rate of return is 10%, and we want to know how much we should pay for that investment now, or the present value. Now for the present value of mixed stream problems, we're not going to use all of the 5 time value of money buttons here on the top left. We're going to use a couple of the functions embedded within those buttons. We're going to use, under the present value button, the CF sub 0, and under the payment button, the CF sub J, and under the future value button, the N sub J. The CF sub 0 button is how much do we have now, or how much we will pay for the investment. Now we will use this for other types of problems such as net present value and internal rate of return calculations, but for now we just need to be certain it is 0. So we're going to hit 0 and then G, the shift button, and the present value. That just makes sure the cash flow we have now is 0. Now we need to enter the cash flows per year. So the first cash flow was $100. So we're going to hit $100. We're going to enter all our cash flows into the CF sub J. So CF stands for cash flow, obviously. So hit G and the payment button. Now our next cash flow is $200. So again we hit 200, G, and the payment button to put in the second cash flow. Now the $200 occurs for 2 years in a row. So we can either enter 200 twice into the CF sub J button, or instead we can hit 2 and then our G shift button and then the future value button to put it in N sub J. The N sub J stands for how many periods in a row a cash flow occurs. So for example, if you had a cash flow occurring 6 years in a row, instead of having to put that in manually 6 times, you can put 6 in the N sub J button, and the calculator knows that cash flow occurs 6 times in a row. Okay. Now finally, our fourth year cash flow was 400. So we hit 400, G, and our CF sub J button. Right. Now we have all our cash flows entered in. 100 for the first year, 200 for the next 2 years, and 400 for the fourth year. Now our interest rate, our required rate of return, is 10%. So we hit 10 and I. And then we're to solve for how much this stream of cash flows is worth today. We're going to hit the F button, the gold F button, and the present value button, which above it says NPV. NPV stands for net present value. So you can see the answer is $679.67 rounded off. So that is the present value of the cash flow stream. Now to clear your entries out of these buttons, again the calculator stores in the numbers you've entered until you clear them out. Again, hit the gold F button and the X greater than or less than Y to clear our financial buttons out. All right, and we can hit clear X button to get our display back to 0. Now you say, well, what about calculating the future value of a mixed stream? We've done the present value of a mixed stream, but what about the future value? Well, in order to do that, you have to calculate the future value of each cash flow individually and then add them all together. So I'm not going to go through an example of that calculation. You would just, again, have to do the future value of, say, the 100 and the future value of the first 200 and the second 200 and so on. Now, many of the calculations we'll do in time value of money involves the interest rate that compounds more frequently than annually, such as monthly, quarterly, or semi-annually. So what we need to do is, when we're entering those different compounding periods, we're going to adjust the interest rate and the number of periods before entering them into the time value of money buttons. Say, for example, we have $100 we're going to put into an account for 2 years at 10% interest, but the account compounds semi-annually. So what we're going to do is divide the interest rate by 2, and we're going to double the number of periods. So you also, since it's semi-annually, for quarterly you divide the interest rate by 4 and take the number of periods times 4, for example. So again, we're going to put it in for 2 years. So it's semi-annually. That's 4 compounding periods. So 4 in. Interest rate was 10%. Note that interest rates are always quoted as annual rates. So even if it says 10% compounding semi-annually, that 10% is an annual rate. So we need to divide that by 2 to get 5 into the interest rate button. Our initial deposit was 100, so 100 present value. Again, we don't have any payment, so 0 payment. And then we're solving for the future value, so we hit the FB button to get our answer of 121.55. Now suppose you have an interest rate of, say, 15.5% that compounds monthly. So you need to divide 15.5% by 12. Now you may be able to do that calculation in your head, but I can't. So I need to use the calculator. The thing about the Hewlett-Packard 12C, it uses a different type of notation than other typical calculators do. So in order to do addition, subtraction, multiplication, and division, you have to hit the enter button after the first number you put in. So again, it's 15.5% compounded monthly. So we need to take 15.5 and then hit enter. Then we're going to divide it by 12. So you hit 12 and then the divided by button to get 1.2917%. So you can see that's a little different than just hitting 2 plus, or 15 divided by 12 equals 1.29. The HP 12C doesn't have an equals button. All right, another type of compounding is continuous compounding, which is compounding every microsecond. So if you're lucky, your bank account might offer continuous compounding on a savings account. So instead of using the time value of money buttons, we're going to use this e to the x button. It says 1 over x, and then in blue below it says e to the x. E to the x is the base of the natural logarithm, and since we're compounding every microsecond, it's kind of an exponential function that we need to use. So again, say we have $100 in an account that earns 7% continuously compounded, and we're going to leave that in for 2 years. All right, so instead of using the time value of money buttons, what we need to do is first take the interest rate as a decimal, so 0.07 times the number of years, so 7, enter, 2 times, of course, gives us 0.14. Now we need to hit our blue G shift button and then our e to the x to get 1.1503. So this is the future value interest factor that you multiply by the deposit of $100 to get our future value. So we just hit enter. Our deposit is 100, and then the times button to see that our $100 grows to 115.03 rounded. If we leave it in account 2 years, that compounds continuously at 7%. One last thing, suppose you wanted an effective rate using continuous compounding if you're given a nominal rate. Nominal rate's the stated rate of interest on a loan. Say we wanted an effective rate. So say we have our nominal rate of 7%. To get an effective rate, hit 0.07 and then our G shift button, e to the x, to get 1.0725, which is a 7.25% effective rate after you subtract the 1. So continuously compounding is the highest effective rate you can earn, higher than daily, monthly, quarterly, so on. Now this concludes the second part of doing basic time value of money calculations using the HP 12C. I hope this has been beneficial.